The Milky Way could be teeming with more satellite galaxies than previously thought. The Milky Way could have many more satellite galaxies than scientists have previously been able to predict or observe, according to new research. Cosmologists at Durham University used a new technique combining the highest resolution supercomputer simulations that exist, alongside novel mathematical modeling, to predict the existence of missing orphan galaxies. Their findings suggest that there should be 80 or perhaps up to 100 more satellite galaxies surrounding our home galaxy, orbiting at close distances. If these galaxies are seen by telescopes, then it could provide strong support for the lambda-cold dark matter theory, which explains the large-scale structure of the universe and how galaxies form. This ongoing research is being presented on Friday, the 11th of July, at the Royal Astronomical Society's National Astronomy Meeting at Durham University. Most galaxies in the universe are low-mass dwarf galaxies, the majority of which are satellites orbiting around a more massive galaxy, such as our Milky Way. The research is based on the LCDM model, where ordinary matter in the form of atoms represents only 5% of the universe's total content. 25% is cold dark matter, and the remaining 70% is dark energy. According to LCDM theory, many more Milky Way companion galaxies should exist than cosmological simulations have so far produced, or astronomers have been able to see. And properties of these Milky Way orphan galaxies showing that many more Milky Way satellites should exist and be observable today. It is hoped that new advances in telescopes and instruments, like the Rubin Observatory LSST camera, will give astronomers the ability to detect these very faint objects, bringing them into our view for the first time. In this model, galaxies form in the center of gigantic clumps of dark matter called halos. We know the Milky Way has some 60 confirmed companion satellite galaxies, but we think there should be dozens more of these faint galaxies orbiting around the Milky Way at close distances. The existence of these enigmatic objects has long posed challenges too. LCDM, otherwise known as the Standard Model of Cosmology. It has led to the Standard Model of Cosmology, and is the most widely accepted model for describing the universe's evolution and structure on large scales. The new research shows that the Milky Way's missing satellites are extremely faint galaxies stripped almost entirely of their parent dark matter halos by the gravity of the Milky Way's halo. Sign up for our free newsletter and get updates on breakthroughs, innovations, and research that matter daily or weekly. These so-called orphan galaxies are lost in most simulations, but should have survived in the real universe. Although the simulations lose the halos of orphan galaxies, such galaxies should survive in the real universe. Could tell us more about how the universe came to be as we see it today. Aquarius is the highest resolution simulation of a Milky Way dark matter halo ever created, and is used to understand the fine-scale structure predicted around the Milky Way, using their new technique. The Durham researchers were able to track the abundance, distribution. Lead researcher Dr. Isabel Santos, the Institute for Computational Cosmology, Department of Physics, Durham University, said, leading to the stripping of their dark matter and stellar mass and rendering them extremely small and faint. If our predictions are right, it adds more weight to the lambda-cold dark matter theory of the formation and evolution of structure in the universe. Observational astronomers are using our predictions as a benchmark with which to compare the new data they are obtaining. One day soon, we may be able to see these missing galaxies, which would be hugely exciting using the laws of physics, solved using a large supercomputer. In mathematical modeling, we can make precise predictions that astronomers, equipped with new, powerful telescopes, can test. Astro, Doer, AC, UK, Eve. 7 contributions 515. It doesn't get much better than this. Do not have the resolution needed to study galaxies as faint as those astronomers are starting to discover close to the Milky Way? Discover the latest in science, tech, and space with over 100,000 subscribers who rely on phys.org for daily insights. If the population of very faint satellites that we are predicting is discovered with new data, it would be a remarkable success of the LCDM theory of galaxy formation. Email. The concept of LCDM is the cornerstone of our understanding of the universe. The model has passed multiple tests but has recently been challenged by puzzling observational data on dwarf galaxies. The Durham researchers say that even the best existing cosmological simulations These simulations also lack the precision required to follow the evolution of the small dark matter. Halos that host the dwarf galaxies as they orbit around the Milky Way over billions of years. This leads to the artificial disruption of some halos, leaving galaxies orphaned. The Durham researchers combined cosmological supercomputer simulations with analytical models to overcome these numerical issues. This included the Aquarius simulation produced by the Virgo Consortium. It also included the Galfer model, a cutting-edge code developed at Durham over the past 2 decades, which follows the detailed physical processes that are responsible for the formation and evolution of galaxies. Their results showed that halos of dark matter which may host a satellite galaxy have been orbiting around the central Milky Way halo for most of the age of the universe as a result. The research predicts that the total number of satellite galaxies of any brightness likely to exist around the Milky Way is around 80 or potentially up to 100 more than currently known. The research puts particular emphasis on the approximately 30 newly discovered tiny Milky Way satellite candidates that are extremely faint and small. Scientists are unclear if these are dwarf galaxies embedded in a dark matter halo or globular clusters, collections of self-gravitating stars. The Durham researchers argue that these objects could be a subset of the faint population of satellite galaxies they predict should exist. Co-researcher Professor Carlos Frank of the Institute for Computational Cosmology, Department of Physics, Durham University said, it would also provide a clear illustration of the power of physics and mathematics. More information: the contribution of orphan galaxies to the ultra-faint population of MW satellites, conference.